Okay, everybody, welcome to the presentation Introduction to the SOLIDWORKS Motion Manager. Today we're going to talk about using the Motion Manager to create animations for your assemblies in SOLIDWORKS. My name is Marlon Banta. I'm a director in the SOLIDWORKS product definition team. So for the materials for this course, we have all the models that we're going to use in this presentation, including a tutorial that's available here at solidworks.com/intro_motion_manager. If you want to review the materials presented in this course, please download that file and you can walk through the tutorial. And the way that I recommend setting up your machine to walk through the tutorial is to first, we'll open this tutorial file. And I have it so that it can be, here on the side, and we'll make SOLIDWORKS. There we go. And then we can slide this guy over and put SOLIDWORKS right there. And I like to go in read mode. And so here you can follow along with the tutorial while you're working in SOLIDWORKS here on the left. So let's go ahead. I'm using SOLIDWORKS 3D Experience connected, and I'll be opening these files directly from the 3D Experience platform. Filter this only to my content. And I'm going to look at the top level assemblies. And so our first model will be this, the plunger. So the goal of this presentation is to teach attendees to use the Motion Manager to create dynamic animations of their SOLIDWORKS models. So if you look in this window, we have the hand crank, and I've gone here and created an animation of that hand crank, and I've also rendered that animation, in this case using PhotoView 360. Animations are also supported, of course, in SOLIDWORKS Visualize. And so we can see that we can create very dynamic representations of our models using the SOLIDWORKS Motion Manager. So what we're going to cover today, we're going to learn the general concept of keyframe animation. Part 1 will be motion study basics. Part 2 will be display changes in the motion study. Part 3 will be using the animation wizard, and we'll show how you can save motion studies to a video file. Part 4 will be animating distance mates, and we'll also include in there animating view orientation changes. And if we have time, I'm not sure that we will, we'll get to these 2 additional exercises. One is interpolation modes, and the second is animating using a camera. So the general keyframe animation workflow in SOLIDWORKS is that you define the model position or display at the start key point and end key point using standard functionality. So we can move components, we have the move command, we have components that are mated together. We can even use distance and angle mates. And you would add key points to refine the motion. And the Motion Manager then linearly interpolates the motion or display change between the start and end key points while respecting the mates in the model. And we'll see more about what that means, specifically related to the mates next. But let's talk a little bit more about this idea of a start and end key point and the linear interpolation between the start and end key point. So in this basic example, we have a ball in position 1 and position 2. And so if those are our start and end key points, we would linearly interpolate between those key points. And so the ball just goes straight over the top of the checkerboard. But that's not, very realistic. When you throw a ball, it tends to sink. We could even add a bounce. And so here we've refined the motion by adding a key point in between what used to be key points 1 and 2. And now we have trying to simulate a bounce. And so those are the 3 key points we've added. And then again, SOLIDWORKS linearly interpolates between those key points. We can refine it even more by adding more key points to make it look as though it has a bounce with topspin, right? And so here we have all those intermediate key points between the start and finish. And we see SOLIDWORKS linearly interpolating the motion of the ball through those key points. So we'll get into this more looking at SOLIDWORKS, but the basic components of the SOLIDWORKS Motion Manager user interface are the Motion Manager feature tree, which is very similar to the model feature manager that we have in SOLIDWORKS. The one difference is that the commands available in this feature tree are only specific to the motion manager. So they're only commands that are applicable to the motion manager. And we'll see that many of those commands are similar to what we're used to in SOLIDWORKS, not in the motion manager. Similar to simulation, we have tabs at the bottom for each of our motion studies. This area right here is the primary working area for the motion manager. It's called the timeline. And here we have the toolbar for the motion manager. And this is the, I call this the time bar. And this is where you either add key points or you can see what the motion is in other areas of the timeline. So let's move on to an example of creating a basic motion study in part 1. So I'm using SOLIDWORKS 3D Experience Connected, and I'm going to be opening my model files directly from the 3D Experience platform. So I'm interested in my content, and I can use this assembly filter to go to the top level assemblies. So we'll open the plunger. Okay, so looking at this, assembly, we can see that I've mated these components in such a way that when I drag this arm, the plunger moves back and forth, and this linkage rod attaches between this plunger and this arm. So we're going to be using these mates, in the assembly to help drive the motion of this motion study. So here we can see the the motion study tab. I can go ahead and add a new motion study. If you don't see the motion study tab, you'd want to come here to Tools, Customize, and there's the option to turn on the motion manager. Okay, so remember the workflow is you define the start position and the end position, and the motion manager linearly interpolates between the start and end position while respecting the mates in the model. So let's first define the start position. What we want to do is come here to time 0. There I just eyeballed it. If you ever want to absolutely 100% dial in to a specific time, you can come here to this command and choose use the time bar, and it puts it in exactly the same position. We do have snaps here. You have the ability here to sort of zoom in and zoom out in the timeline. But let's just say that this will be our initial position, and then we're going to come out to time 5, and we're going to move the arm out to here. And so I have my start and end position, and the motion manager, when I hit calculate, linearly interpolates between the start and end position while respecting the mates in the model. If I want the arm to go back, I can put time 10 and try and eyeball that, you know, and we'll hit calculate. But you'll see that, you know, I didn't quite get the position that I wanted. And so a trick that you can do with keyframes is to come here. I can delete that keyframe, and I can copy the time 0 keyframe and paste at time 10. And that's a very important technique so that you can get something back to a position in a previous keyframe. So I copied the key point from here and pasted it here. And we can see that it's providing all sorts of information. That little icon on the left, the hand grabbing the part, says that key point defines a motion change. There is not an explode step. There's no appearance defined by that key point, and the display is shaded. And it also tells you which component's being moved, so it's arm left in this case, and that we're at time 10. So now when I play back the motion study, we see that the arm swings from its initial position to that point position at time 5, and then returns to its original position. So let's look at a few more changes that we can make in a motion study just using keyframes. So one thing you can always do is you can always put the time bar and see where the assembly is at that point in time. And if I have the time bar at 2 seconds, that's where the assembly is at 2 seconds. If I hover over one of these key points, then we see where arm left is moved to at time 5, while the rest of the assembly remains where you are, where the time bar is located. We can go out to here and see where arm left is at 10 seconds. So again, there's many manipulations and changes you could make to your animation without really interacting with the model. So let's say in this instance, I want to move this key point to here and see the effect of speeding up the swinging out and then slowing down, swinging back. One thing you'll notice that here we call this the calculation indicator, and it went from solid yellow, and solid yellow means that all of the frames have been calculated and are up to date. Yellow with these dashed gray lines means that there are frames that have been calculated, but they're not up to date with the latest change. So if I were to play this motion study back, you can see that it's not respecting the movement to this key point. It's swinging out in even time to where it's swinging back. But if I hit calculate, now we see the arm swing out much more quickly to its position at time 2, and then slowly start to come back. And so there it is reflecting the change that I made in this key point. The next manipulation that we'll look at is setting a span of time when nothing happens in an animation, which is quite important. You can imagine having 2 components move initially, but you want the third component to wait till those initial 2 components are in a new position. And so you would define a span of time when nothing happens in the animation. And so if we come here, let me show you what I mean. If I copy this and paste it to time 5, now we can see the calculation indicator. It's up to date until time 2, and then it's out of date after time 2. So we're going to hit calculate. We can see now that there's a span of time when nothing happens in the animation between 2 and 5, because we've copied the position here and made it the same as the position, or we've said that the position at time 2 and at time 5 are the same. So if we play this back, it swings out quickly to that stretched out position, stays there until time 5, and then swings back. So in the tutorial, that's the end of part 1, and we'll get on to part 2 in a minute. Let's take a few minutes to look at some of the components of the MotionManager interface in a bit more detail. So these we call key points. A collection of key points comprises a keyframe. So key point is our term, keyframe is an industry term. We mark the transition between key points using these transition bars. And in this case, green indicates that I've actually taken arm left and moved it out to time 5. And that is what we call a driving change bar. And these yellow change bars are driven change bars. These are all the components that come along for the ride because they are mated in a mating scheme to arm left. So when I move arm left, these bolts, the linkage connectors, all of those things move with arm left because how they're mated together. This is the time cursor, sometimes called the time bar. And of course, we talked a bit about the calculation indicator up here. And so the 3 states are no frames have been calculated, frames have been calculated and they're up to date. And what we're showing here is frames have been calculated, but they're out of date. So here we have tree filters in the MotionManager, so you can filter only to driving components, only to components that are moving in the motion study, in the animation. There's the calculate button, so here we have play from start, play from the time cursor location, then of course stop. And then we have the motion engine selector, and here is where you would transition. You could go from a keyframe animation like we're talking about today You can use video game physics in basic motion, so you can actually have a ball drop into a cup or something like that. And then here is also where you would select that perhaps you'd want to use motion simulation. And that is, true dynamics, where you can understand the accelerations, the forces between components, the velocities, things like that. So that's where you would do a motion simulation. So a few hints with motion studies. One, remember that any supported model change will be written to the motion study at the time cursor location. So be very conscious of that. If you're, make sure you don't move a component in the assembly unless you actually want to edit the motion manager. And we'll see a little bit more later on how we have some controls for that as it relates to view orientation changes. The next is to script your motion studies. It doesn't have to be elaborate, but just a very quick outline of what you intend to see in the motion study can be very helpful. And we find that it's very helpful in that it can help you avoid adding extra keyframes. You find that you have a much more efficient motion study, a motion study that is easier to analyze later on and make changes to later on when you script your motion studies. And of course, the last one is to verify the effects of each change. So hit calculate and play back. We're using rather simple models in these examples, rather small models. But if you're using very large assemblies, you'll start to see why we don't calculate automatically. And it is possible to add multiple key points without calculating the assembly. And what you want to do is you want to avoid a scenario where you've added many key points and you've added some of them incorrectly, and you're not aware of the impact of those incorrect key points on your motion study until you hit calculate. So make a group of changes, calculate and verify, make a group of changes, calculate and verify. So let's next get into looking at display changes we can make to the motion study. So first we looked at component position changes. Now let's look at display changes. So things like hide show, display mode, which is wireframe, shaded shade with edges, and appearance, and also transparency. The first thing we want to do is we want to create a copy of this motion study. And so you can do it in several ways. One, I can come here and say copy study, and now I have an exact copy of that motion study. I could also create a new motion study and then come here and select all, or I can, drag. And this is helpful. The drag is helpful because what if you only want to copy a certain number of key points to the new motion study? You don't have to copy all of them. But in this case, we'll come here, select all. Select all, Control C to copy. Come here to motion study 1. You have to go right here and then paste. So now we've essentially copied motion study 1. So many ways to take data from information from one motion study to another. Okay, so in here we have kind of a basic script of what we want to have in this motion study. I've kind of written this out just like we recommend. So in this basic script, we have both arms are visible until 5 seconds, then gradually transition to transparent at 10 seconds. The base, this part here will transition from its current color at 5 seconds to blue. Its current color at 0 seconds to blue at 5 seconds. And then the plunger, this thing right here, will remain shaded until 5 seconds, then we'll transition to completely wireframe at 10 seconds. And so we can already see in our script that we need to have key points to define a span of time when nothing happens. So the plunger and the two arms need to remain their current display for 5 seconds until they start to transition to their new display when it will be at time 10. And so very similar to what we did, when we copied this key point here, we want to come here and expand, and we're going to copy the appearance keyframe. So this is we have multiple types of keyframes for each component. This is component motion. These are explode steps. We'll get to that in a bit. And then these are appearance. So things like, the appearance itself, the color, hide, show, display mode, transparency, things like that. So we're going to copy the appearance keyframe at time 0 and paste it to time 10. Let me zoom in a little bit, just so it's not so small. And then we'll do that again for arm right. And we should also do that for plunger, right? Because we have that as one of our items in the script. So we're going to come here to plunger. We're going to expand it, copy that, and paste it there. Okay. So we've defined a span of time when nothing happens. And then what we want to do is come here, and we can, set right here. We can set it to hide, hide those components. We have all these other options. So let's just say at time 10, we're going to hide the component. And we're going to come here and hide arm right at time 10. So when we play back the animation, you notice that we don't have to calculate, because you don't have to calculate for display changes. But when we play back the animation, these two arms are visible until time 5, when they start to transition to be hidden at time 10. The next thing we're going to do is we're going to change the color of the base. So we'll go back to time 0. And the base is going to transition from its current color at time 0 to a new color. So we go to appearance. We're going to say it transitions to blue. There we go. At time 5. Now, you can sometimes, when you're editing the appearance of a component, you can actually go in and write to the component and add appearances to the face, feature, or body of a part, component, in an assembly. That's not possible in a motion study. Only component level, right here, appearances are available in a motion study. So we'll hit OK. And when we play this back, we see here it's transitioning from brown to blue. And these arms are transitioning from shown to hidden at time 10. Okay, and the last thing we'll want to do is we're going to take the plunger, and it will transition to be a wireframe at time 10. So if we put the time cursor here, we look at the plunger, and we want it at time 10. We're going to change the component display right here to be wireframe at time 10. So now if we play it back, the base is transitioning to blue, the plunger and the arms, their display remains the same, but they start to transition the arms to hidden and the plunger to wireframe at time 10. So one other keyframe manipulation is you can come to any key point, and of course you can delete it. So that removes the key point entirely. So if I deleted this, it won't transition to blue at time 5. But you can also suppress it. So it remains there, but very much like you're suppressing a feature or component in SolidWorks, you can suppress a key point. And so here we'll see that the base doesn't change its color because we've suppressed the key point that marks the change in appearance or color. Okay. In part 3, we'll talk a bit about Animation Wizard. And the Animation Wizard is a great tool for when 4:50 in the afternoon on Friday, someone comes to you and says, "Hey, can I get a slick representation of that assembly you've been working on?" And so very quickly, you can create a very dynamic animation of your assembly using the animation wizard. And what the animation wizard does is we use it to add view orientation changes, sort of very large view orientation changes. We can rotate the model, and we can also add explode and collapse steps. It's also where you would take motion changes defined in the make controller and bring them into a motion study. And it's also where you would define a solar access study. So if you've added sunlight to your model, you can have the sun move at different positions, different times of the day, and it's, physically accurate using the MotionManager. I'm sorry, using the animation wizard in the MotionManager. One thing to note is that rotation about when we talk about the axes, when we're defining rotation, X and Y are in screen coordinates, and Z is also in screen coordinates, and Z is normal to the screen. So that's what rotation means in the animation wizard, or what those axes are. So let's come back to SOLIDWORKS. We'll close that model, and we're going to open a bit larger model. We're going to come here and open the clutch assembly. Let's bring back our tutorial. Okay, so in this assembly, you can see that we've added explode steps. So that's the exploded view, and of course that's the the collapsed view of this assembly. You can change the height of the MotionManager here. I will say that the grab point is a little bit small, so it can be tricky to catch that grab point. Okay. And so what we're going to do is come in here to the animation wizard. And what we want to do is we want to have this model rotate twice about the y-axis for 5 seconds, explode for the next 5 seconds, and collapse for the remaining 5 seconds for a total of a 15-second animation. So if we come here to the animation wizard, click here, and we want to rotate the model about the y-axis, we'll go clockwise, and we'll say 2 rotations for a duration of 5 seconds starting at time 0. And so here you can see that it added view orientation keyframes. We notice that the change bar between view orientation keyframes is black, and the key points themselves are black. And so if we play that back, we see it rotating twice about the y-axis starting at time 0, ending at time 5. So we'll come here and we want to explode the model. And we're back in the animation wizard. We want to explode for a duration of 5 seconds, and we want it to start at time 5, so after it's done rotating. And here we've added explode key points. And so these are component motion, but because they're explode, we mark the transition using an orange change bar. And you can see right there that it has the little explode symbol being used for that key point. So if we zoom out a little bit, we'll calculate this. We can see that it's exploding for a duration of 5 seconds. So it rotates twice about the y-axis for a duration of 5 seconds, and then at 5 seconds, it begins the process of exploding the assembly. And of course, we can use the animation wizard to go backwards. And in this case, we're going to collapse for a duration of 5 seconds, starting at 10 seconds. And we'll calculate those key points or keyframes. And so there is our assembly defined in our motion study defined in the animation wizard. Okay, so you'll of course want to share this animation. You could send an e-drawing that includes the animation. You could of course send, have the person open this assembly. But what's also very common is to save it, of course, to a video file. And so here is our save animation option. And let's save it in, no, we'll just save it to the desktop. So, okay, so we'll save it to the desktop and we'll say clutch animation. We have all kinds of options here, you know, flash video, AVI. I like MP4. You could also save as a series of individual images. And this is very important when you're rendering. You know, it takes a while to render each frame and you want to save as a series of individual images and then use video editing software to recombine those images into an animation. What that allows you to do is it's very easy if you want to make a change to maybe remove these 20 or 30 images and replace them with something in your animation. But also if you want to, like, let's say, make some of these images darker for whatever reason you decide in post-processing they should be darker, then it's easier to do with the individual images. And you can go and edit the individual images or as a group take them and make them all darker. So in this example, we're going to use MP4. So there's clutch animation MP4. I could schedule this. That's very important when you're rendering an animation. We have options as to whether or not to do the entire animation or a certain time range. But I'm going to come here and hit save. Here it's asking me if I want to recalculate. I'll hit no. But here it is. Now saving out the animation. And when it's done, we can find that animation right there on our desktop. And if we play it back, you see it rotates twice about the y-axis, then explodes, and then it collapses. Okay, so next, we're going to talk about how you can incorporate view orientation changes into your animation. And we have two controls that are very important. The first is to disable view key creation. And what that does, if you remember earlier, I said that every applicable change will be written to the to your motion study at the time cursor location. And invariably, you'll be working with an assembly or a model, and you make small view orientation changes because maybe you need better access to this one component in order to grab it. We have this option to disable view key creation to prevent those small changes in view orientation that you're adding just so you can select different things, to prevent those from being written to the motion study. And then the next one is disable playback of view keys. And we'll show you in the next example how that's important. But with these two controls, what's recommended is that you make all the changes related to the components first. So component motion, position, whatever, display, hide, show, appearance, display mode. You make all of those first with disable view key creation, turned on. So we're disabling view key creation. And then last, you make your view orientation changes. So turn off disable view key creation and make your view orientation changes. So let's go back to SOLIDWORKS. All right, I'm going to close that model. Come here, open. So look for my content. Again, we'll look for the top level and we want to open the plunger hook. Okay. So we'll talk about view orientation changes, but also we're going to talk about animating distance mates. And so what's important is, in the first example, I kind of eyeballed the position of the plunger at time 0 and then time 5. But if you want to get the plunger to be in an exact location, the best way to do that is to either add a distance or an angle mate and animate those distance and angle mates in your motion study. So for example, here we have this distance mate, and this distance mate sets the position of this component. If I were to suppress the distance mate, I can move this, move this up and down. but I'm setting the exact position of this collar using this distance mate. So if I unsuppress it, you can see, of course, that I can come here and set that to be 4. And if I rebuild the assembly, it goes down. So let me move that back to 0. There it is. Okay. So if we go into the motion study, you can see that at, let's say at time 5, and we're going to set this mate to be 4 at time 5. And then at time 10, we want it to be 0. And remember, I can copy that key point and paste it to time 10, but I don't have the same problem that I had when I was eyeballing position, because I know the exact position, and I can just come in here and set it to 0. All right. Of course, pay attention to the calculation indicator up here. So we haven't calculated these key points yet. So I have to go ahead and hit calculate. And so now we have an animation where it's animating using that distance mate. And so we're setting the exact position at time 0, 5, and 10 using that distance mate. We have different playback modes here in the Motion Manager. So normal just goes from time 0 to time 10. Loop goes from time 0 to time 10 and back to time 0. Let's speed this up so we're not waiting for it to play back. So if we double time it, there it is, double time, and then loop. It kind of hops back to the beginning. And the other option is, of course, reciprocate, where it goes from time 0 to time 10. They also call it ping ponging, and then 10 to 0, and then 0 back to 10. So let's go back to loop. So while a motion study is playing, you can change the view orientation. You can zoom in to different parts of the motion study. But you'll see that when it gets back to time 0, it resets the view orientation. And that's because I have, I'm enabling playback of view keys. So I've not checked disable playback of view keys. So what I can do is I can disable the playback of view keys. And now, those changes that I make in the view orientation while it's playing stay, and I don't jump back to the time 0 view orientation. Okay, so let's look at how we can add view orientation changes to our motion study. Gonna go ahead and hit stop, move back to time 0. I'm gonna enable playback of view keys, and I'm gonna turn this off. So we're not going to be disabling view key creation. And again, the reason we do that, the reason we have that control is that, every little view orientation change you make gets written to the motion study, and it's not always clear that those view orientation changes are intentional. So here we have, a very different motion study with those view orientation changes. And we see quite commonly that, if I need to move this one component at time 6, I'll often make a view orientation change, to allow me to better access, even small view orientation changes to allow me to access that component. And maybe we don't want that, written to the motion study. It can be overly dynamic and a little bit confusing. All right, so we'll come here and we're going to delete those view orientation changes. And what we're going to do is we're going to start, we'll just go top, at time 5, we'll go, front, and then bottom at time 10. So now we have this motion study. It starts at the top view orientation, shows you the front, and then gets to the bottom throughout the animation. And this is a great way to create very, dynamic motion studies. this would be an interesting motion study without that collar moving up and down. But here, we're going from, top to front to bottom as different key points within the motion study. Okay, and there is an advanced motion manager presentation, and in that we really get into using cameras, which is another type of view orientation. Cameras allow you to go inside the component, allows you to follow a component exactly. It's very much similar to a camera. All right, so those are the main topics that I wanted to cover in this presentation. Looking at the time, we have time for one more example. But what I would like to do is talk a little bit about ways in which you can participate in the development of SOLIDWORKS. This is a slide I entitled Helping SOLIDWORKS Help You. And essentially, we have varying levels of commitment. So this is a low level of engagement. And that's just turning on the performance logger. So you go to Tools, Options, Enable the Performance Logger. And what that does is it sends a fully anonymous record of the commands that you used within your session of SOLIDWORKS. It doesn't tell us any personal information, and it doesn't tell us any of the values that you entered in those commands. We can't tell if you had a 10-inch or a 300-inch, fillet in your model. We can only tell that you press the fillet command, and that's very valuable information for our annual research. Next is go to the customer portal and submit an enhancement request. Members of my team review those constantly, and we use that as part of our research to understand and get a sense for what customers are asking for, what enhancement requests they're looking for, especially in our release planning. Often you'll see surveys sent out from SOLIDWORKS, and again, these are very informative for us. We'll skip the middle one and get back to that. Certainly, there's the beta program, and when you sign up for beta, there's within the agreement is a non-disclosure clause. There's alpha testing, and so quite commonly, you'll get a request from SOLIDWORKS to participate in testing of software. We ask you to sign a non-disclosure agreement, but you can test software long before it goes to beta, and sometimes even review the next level down specifications before we even make the change in the software. And this really gives our customers a lot of influence in driving the future direction of the product. A very important part of our annual research is that middle item, and that's customer visits and consulting. I know that it's late 2021, and people are not thinking about in-person meetings the same way that maybe we did a couple of years ago. But when things get back to normal, we'd be, within my team, we do many customer visits throughout the year. And this is a one-on-one discussion to understand your experience using our software. And again, it's a very critical part of our annual research. So this concludes the main part of the presentation, but let's go ahead and do an additional exercise. Again, you can get the hands-on materials by going to solidworks.com/intro_motion_manager. It's all the models that we looked at and also the tutorial that we used. But for the additional exercise, this one's kind of fun. We'll look at interpolation modes. Let me open. All right. So here is this very simple assembly, and all it does is we have a limit mate that controls the motion of this component between 0 and 10. And so if we look at this this motion study, basically, we're going from 0 to 10, and let's set that to be normal playback mode. And so we said that we go from the start position to the end position, respecting the mates in the animation throughout the, between the key points, and that we linearly interpolate that position. Well, we have this one option here called interpolation mode, which tricks that notion of it being a linear interpolation. And so our interpolation modes, by default, it's linear, but we have snap, ease in, ease out, ease in, ease out as a combination. So let's, again, look at it as a linear interpolation. It's constant speed or constant velocity from 0 to 1. I can come here and set snap. And so snap, basically nothing happens until time 5, and then it'll snap to respect the time 5 key point at the very end. We have ease in, where it accelerates slowly at the beginning until it gets to constant velocity about halfway through. So there it starts slowly, and then the speed remains constant about halfway through the span between the key points. Ease out, which for some reason is my favorite. I guess I've been watching those SpaceX landings where it goes constant velocity and then gently comes to rest at the end. So there it is, constant velocity, and now it gently comes to a rest at the end. So these interpolation modes are a way of tricking the notion of linear interpolation between key points and giving a different characteristic to your motion study. So everyone, thank you very much for watching my presentation. Please download the presentation materials and walk through the tutorial, and of course share this presentation and the tutorial materials with other SOLIDWORKS users.